Welcome back to AlgoJS. Today's question is LeetCode 103, binary tree zigzag level ordered traversal. So given the root of a binary tree, return the zigzag level ordered traversal of its nodes values from left to right, then right to left for the next level and alternate between. So in example 1, we have this binary tree and we want to return where we go 3, 29, 15 and 7. So if you think about it, we're going to the right at this level, going to the left at this level, going to the right at this level, and so on and so forth. It's pretty self-explanatory and it's a good introductory question to breadth first search. So we are going to be using breadth first search for this. The kind of way we want to think about this is to have some kind of flag to determine which direction we're going in. We could actually even use depth, right? So say this is 0 depth, this is the first depth, and this is the second depth. At 0 depth, we're going right. At the first depth, we're going left, and at the second depth, we're going right. Now if we look at these, 0 and 2 are even. So if it's even, we go right. If it's odd, we go left. And based on breadth first search, we can just do this by pushing into level if it's even, or unshifting if it's odd. So what this will look like with breadth first search is we'll have a queue. We'll insert the root at the start of the queue. We'll keep track of the depth. So depth is going to be equal to 0. We'll also need a result array which we're going to populate. And we're going to need a level array, which will be each individual level that we visit. So this level, then this level, then this level. So that's everything. So if we start the BFS, so we shift off of queue, we look at 3, we check its children, we have 9 and 20, which we can add into queue. Now, because 3 is an even depth, which is 0, we're going to push this into levels, like so. Now we've checked all the values at this level. We can increment this. We can push levels into results. So 3 goes in here. We can reset that and then shift off of queue again. So we visit 9. 9 doesn't have any children, but 9 is at depth of 1. So that's odd. So we're going to be going backwards. And the way we do that is we unshift into levels. So if we unshift into levels, we add 9 in there. We've checked this value now. So that's been checked. We shift off of queue again. We have 20. 20 has 15 and 7, which can be added into the queue. We look at 20. 20 is at the same level, so it's at 1. So we unshift into levels. So 20 goes at the start. And as you can see, it's the correct order now because it's going from right to left. 20 has now been seen, and we can push level into results. So 20 and 9. Reset that, update depth to 2. So depth is now 2. We shift off of queue. We have 15. We check its children. They're null. So we can push, seeing as this is at depth of 2, which is even, we need to push this value into levels. So we can add that there. Now 15 has been seen. We shift off of queue. So we look at 7. 7's children are both null. This is at depth of 2 again, so we push in to level. Now 7 has been seen. We can push level into res, so 15. Okay, I meant to put 7 in there. So 7 goes in here. The queue is now empty, and we can exit the breadth first search and then just return res. So that's the basic walkthrough of the solution. Time complexity is going to be O of n, because it's breadth first search, where n is the number of nodes in the tree, and space complexity is also O of n. So firstly, let's cover the case where root is equal to null. We can just return an empty array. Const q is equal to an array containing root. Okay, so we've initialized the queue there. We need results, and we're also going to need depth, which we're going to update throughout this. So let's start BFS. While q.length, we need to initialize level, which will be an empty array, and then we can say level size is equal to q.length. Now while level size, we're going to extract the current value, which is going to be q.shift. Now we need to check whether this current value has a left and right child. So if current.left is present, then we can just push into q current.left. So we're constantly updating the queue, and we'll do the same for right, because we want to check all nodes exactly once. And now we make the check if the depth is even or odd. So if depth modulo, so the remainder 2 is equal to 0, so if it's even, we can push into level the value of current. Else, we're just going to unshift that value. And as soon as we're using a while loop, we're going to have to decrement level size. And then once we exit this while loop, we'll push into res, the level. And then we need to increment depth. Finally, let's return res and give this a go. Submit it. And there you go.